Today what we're talking about is lesson 85, the Pythagorean Theorem. Usually this lesson is a nice review for freshmen taking Algebra 1 because we hammer the Pythagorean Theorem really hard in middle school. That's a concept that you should come out being very confident with using. So if it's not, that's fine because we're going to go through all of it right now, but hopefully you see it as a nice review. This first slide here, it says, if a triangle is a right triangle with legs of length A and B and a hypotenuse of a length C, then a squared plus b squared equals c squared. This is the Pythagorean theorem. Now, A and B are always our legs of the triangle. We can identify the legs of the triangle by looking at the right angle symbol. The right angle symbol is always touching A and B. It doesn't matter which one you name A or which one you name B, as long as you know that those are the legs. C is always the hypotenuse, which is always opposite of the right angle symbol. Okay? So a squared plus b squared equals c squared. Now let's practice using this. Example 1 says, use the Pythagorean theorem to find the missing side lengths. So, on A, I have 12, 16, and C. I can see that I have my right angle symbol touching here and here, so I'm going to always, whenever I use the Pythagorean theorem, I always rewrite it. A squared plus b squared equals c squared. Instead of A, I'm going to plug in 12, square it, plus b, I'm going to use 16, square it, equals c, because that's the name of the side that we're missing. So I'm just going to use whatever variable it is that they give me and square it. So I have 12 squared, which gives me 144, plus 16 squared, which gives me 256, equals c squared. Now I'm not ready to get c by itself yet. I still need to combine these two, so whenever I add those together, I get 400. 400 equals c squared. Now we should also remember that the opposite of squaring is square rooting, so I'm going to cancel that square by square rooting. What I do to one side I must always do to the other, so those two things will cancel each other out. We find that c is equal to 20. That's my final answer. Oops, nope, I don't want to go on. Not ready yet. Okay, the next one is B. So I see I have a right triangle and I'm missing a side length. I'm going to use the Pythagorean theorem, so I'm going to rewrite it. A squared plus b squared equals c squared. Okay, my right angle symbol is touching these two sides. So I have 3 I'm going to use for A. 3, square it, plus, instead of b, I'm going to put the other leg, which is t. Square it equals my hypotenuse, which is across from the right angle symbol, so 5, and square it. 3 squared is 9, plus t squared, doesn't change, equals 5 squared, which is 25. So I'm going to subtract 9 from both sides. I get t squared equals, when I subtract here, I get 16. To get t by itself, I must take the square root because it's the opposite of squaring. What I do to one side, I must do to the other, so I get t is equal to 4. Final answer. On C, similar situation. I have a right triangle. I have one side missing, so I'm going to use the Pythagorean theorem. Okay, so my right angle symbol is touching these two sides. So I know these are my A and my B. Instead of A, I'm going to put K, and I'm going to square it. Plus, instead of B, I'm going to use 32 and square it, equals C, which is 40, and square it. So K squared just comes straight down. Oops, I put equals instead of plus. Just comes straight down because I can't change it. So then when I square 32, I get 1024 equals 40 squared is going to give me 4 times 4 is 16, and tack on those two zeros. So to get K by itself, I need to subtract 1024 from both sides. So I get that K squared is equal to 1600 minus that 1024 gives me 576. Now I can cancel that square by taking the square root on both sides, which gives me that k is equal to 24. Final answer. This one, I want you to do, I want you to do it on your own paper, okay? Pythagorean Theorem, and I want you to just round, if you need to round to 2 decimal places, okay? Pythagorean triple. These mainly are just so you can think of triangles very quickly, okay? If you still don't recognize that a triangle is a Pythagorean triple, it doesn't really matter. You can use a Pythagorean theorem and you'll be able to figure it out, okay? But a Pythagorean triple is 3 non-zero whole numbers that represent the lengths of the sides of a right triangle. So, for example, a 3, 4, 5 triangle, 3 squared plus 4 squared equals 5 squared, 3 squared is 9, 4 squared is 16, 5 squared is 25. Okay, so 25 is equal to 25. That is true. So a Pythagorean triple, that could be any multiple of this also. So if I multiplied each of these by 2, well, that would give me 6 here, 8 here, and 10 here. Well, let's check that. 6 squared plus 8 squared equals 10 squared. 6 squared is 36, plus 8 squared is 64, equals 10 squared, which is 100. So I have 100 equals 100. That is true. Okay? Any multiple of this 3, 4, 5 is a Pythagorean triple. Okay? So on this one it says determine whether the given side lengths form a Pythagorean triple. So first of all, we just said the Pythagorean triple is 3, 4, 5. Has to be a multiple of this, okay? If you aren't recognizing the multiples, you can check this because it's obviously going to be the two smaller ones will be A and B, and then the larger one will have to be C. Your hypotenuse should always be your largest side. So 4 squared plus 5 squared, does that equal 6 squared? 4 squared is 16, 5 squared is 25, does that equal 36? Well, when I put those two together, I get 41, which is not equal to 36. So, no, it is not a Pythagorean triple. Here, I have 9, 12, and 15. My Pythagorean triple is 3, 4, 5. Okay, is this a multiple of those? Well, 3 times 3 gets me 9. 4 times 3 gets me 12. And 5 times 3 gets me 15. So I can see, without doing any of the work, that yes, this is a Pythagorean triple. If you are not someone who can see that, check it. Okay, I have A, B, and C. So 9 squared plus 12 squared has to equal 15 squared. 9 squared is 81. 12 squared is 144. 5 squared is 225. So when I add those two together, 225 is what I get, which means that I have a Pythagorean triple. Okay? I think that's maybe the last. Oh, there's one more. Okay, this is 15, 16, and then radical. The radical bar didn't show up there. 481. Okay, so the square root of 481 is just 481. So they're saying that this would be A, B, and C. Let me change the mode of this calculator. Okay, so I would have 15 squared plus 16 squared equals 481 radical 481 squared. Okay, now whenever I do one like this, I have 15 squared gives me 225. We just talked about that one. Plus 16 squared is 256 equals the square and the square root. Those cancel out, so I just have 481. Okay. So I need to see if 225 plus 256, yes it does give me 481. So that one would also work. Okay. Example 3, a ladder that leans against a building forms a right triangle with the ground. So I'm going to draw a building. This is my building that I drew. It's lovely. Myelin C2 here. Okay, this is my building, and there's a ladder that leans up against the building and forms a right triangle with the ground. That right triangle is right here. Okay? It says that the ladder is positioned 6 feet from the building and reaches a height of 20 feet above the ground. So 6 feet from the building, this distance is 6 feet, and this distance, the height, is 20 feet. Find the length of the ladder. I want to know what this distance is right here, the length of the ladder. So I'm going to draw a better triangle. I have 6, this is my right, this is my 20, and this is the side I want to know. So to the nearest tenth of a foot, I want you to find that answer on your own paper. I hope that you've taken good notes, and I'll see you in class tomorrow. Have a good night.